Assalamualaikum warahmatullahi wabarakatuh. Now I would like to show you the example question of Jacobi method. This Jacobi method is to solve the linear equation. So in this question, we has know that the initial vector is x not equal to 0 and apply the stopping criteria using this value, which is s to the power of k must be minus s to the power of k minus 1, which is must below than 0.005. So I will not show you this example because this is the same example as been written in the note. So I will show you this. This question show that there are 4 times 4 matrix to be solved using the Jacobi method. First of all, we have knows that the initial vector is all equal to 0. So we transpose it to in this form. And then after that, we write the augmented matrix from this linear equation. So we get this value of matrix. So we must make sure that the matrix A is diagonally dominant matrix, which means this diagonal line must be the maximum value of each row. Maksudnya value diagonal tengah ni semua kena bagi besar bagi setiap row dia. Macam ni satu, dia bukan maximum value. Satu ni bukan maximum value dalam row ni. Satu ni pun bukan maximum value dalam row ni. So ini pun sama juga. So apa kita perlu buat? We exchange the row 3 with row 4 and row 1 with row 2. So we get this new form of matrix. So we check the matrix A trigger is the maximum value in its row. 3 also maximum is in its row. 4 also maximum value of its row. And also here 4 also the maximum value of its row. So we get the diagonally dominant matrix. This is the example. So 3 is maximum value more than the value of 1 plus 1. So it is pass. Same here, pass. We must make sure that all the value must be modulus. So we get the value, total value. Okay, then after that we write the linear equation of each row. So next is row 1, row 2, row 3, row 4. So what we want to do with this all 4 equation, for the row 1, we must make sure that x1 ni sebagai tajuk. So we change all the value to the right hand side like this. We get this value. For the row 2, we choose x2 sebagai tajuk. So we get this equation. Row 3 also we use x3 sebagai tajuk. And then row 4 also we change it as a tajuk, and then we get this equation. So each unknown x value we must put k here and k minus 1 in right hand side. So and then we construct this table for iteration method. We write all the value of x1, x2, x3, x4 in this table. So this k, we add this iteration, we just put here how many iteration we do. So this is the not the initial. We have assumed that it is all 0 for all unknown. So we put it all 0. After that, here we put the first value, the first iteration. How to get this value is x1 is from this equation. We put all the x2 and x4 with the value of x2 x4 before the first iteration, which is before iteration is 0. You look at here, x2 is 0, x4 is 0. So we put there, and then we find 1 over 3 times negative 3. So we get negative 1 value here. Okay, so same with x2. x2 also, how to get this value? We follow this equation, 1 over 3 times 2 plus x1. This is the iteration before value. So iteration before x1 is 0, x3 is also 0. So we put 0 0 here. 1/3 times 2 equal to 0.667. Okay, before that, I use 3 decimal place below because I want to follow this iteration limit. So I choose all the value equal to 3 decimal places. Again, after that, x3 also same, 1/4 equal to 6 minus x2 before is 0, x4 before is 0. So we get 1/4 times 6 equal to 1/5. Also same with x4. From this equation, x1 equal to 0, x2 equal to x3 equal to 0, and then we get the value of 3. 1/4 times 12 is 3. So how to get this limit, syarat limit dia. So this value multiply tolak dengan value sebelum ni atas dia. Ni pun sama, tolak dengan value atas dia, ni pun tolak dengan value atas dia, ni pun tolak dengan value atas dia. So 1 tolak 0 adalah 1. Must be modulus Maknanya kalau negatif pun kena modulus kan. 0.67 ni tolak dengan value ni. So dapat 0.67. 1.5 3. So value apa kita letak sini, kita adalah value perbezaan yang paling besar. So 1 ni 0.67, 1.5, 3 ni tolak dengan sebelumnya semua. Confirm yang besar adalah 3. So kita letak 3. So next method 2 also same method as 1. But in this formula x2 we use the iteration before 2 which is 1. So contohlah ambil satu-satu. x1 here 1/3 negative 3 plus x2. x2 yang sebelum 2 ni adalah 0.67. Kita letak 0.67 kat sini. x4 3. Kita letak sini. So akan dapat value ini. Yang ini dalam equation ni kalau value ni negatif ke apa, follow je, letak je dalam equation. Just untuk syarat limit value ni je yang kita moduluskan negative value. So sama juga, kita cari perbezaan dia. Ni tolak dengan ni 0.78, ni tolak dengan ni 0.166. So we get dapatkan dia punya perbezaan. Kita cari yang maksimum adalah 0.78. So kita letak 0.78 kat sini. So make sure lah sampai dapat the stop iteration limit dia 0.003 kurang daripada 0.005. So stop iteration. So we get the value of x unknown here equal to this is x1 value, x2 value, x3 value, x4 value. This is the last value we put here as the answer of this 4x4 matrix. So that's all. Thank you.